For a rigid body to be in equilibrium, the net forces as well as the net moment about any arbitrary point O must be equal to 0. So say there was a rigid body of this shape in the xzy plane. And there were forces going into and out. Therefore, for a rigid body, the forces would equal to 0, meaning the forces in the fx direction equals 0, as well as the forces in the y direction. The moment would also equal to 0 about the point O. Now we will talk about reaction forces. Reaction forces are generated when the motion due to the action is impeded. Suppose there is a beam. And on top of that beam is a car. This would mean there are forces acting down on the beam from the car, and in return there will be reaction forces from the beam to the car, thus making it in equilibrium. Now let's say there is a beam, and on top of that beam is a car. Therefore, there would be forces acting up from the beam to the car, denoted as RA and RB on each side of the beam. This would then cause forces downward to the beam from the car, each of 50 kilonewtons, which then can then be represented as one downward force, as denoted R. Now R can be denoted as 50 kilonewtons plus 50 kilonewtons, since the car is symmetrical, and that would equal to 100 kilonewtons. Therefore, to calculate RA and RB, we use equations of equilibrium. Therefore, in the x direction, fx equals to 0. However, as there are no forces in the x direction, then it does not need to be calculated. However, in the y direction, there is both RA, RB, and R. Therefore, using equations of equilibrium, RA plus RB minus R equals to 0, as upwards direction is positive. To solve for RA and RB, the moment about A needs to be taken into account. Since RA is a pin joint, the moment about A is 0. Therefore, R times the distance to A, which is 2.5 meters, negative since it's in the clockwise direction, plus RB times the distance to A, which is 9 meters, in the positive direction, equals to 0. Therefore, we can work out RB by just simple mathematics. And RB equals to 27.78 kilonewtons. Subbing RB back into the original equation of equilibrium, we can work out what RA equals to. RA equals to 72.22 kilonewtons. And since both RB and RA are positive, they are in the upwards direction.